Good evening, everybody. Welcome to the next Brunswick Astronomical Society. This evening, we welcome, as one of our members anyway, Andrew Kirton-Vaughan, who hails from north of the border. So, Andrew Kirton-Vaughan studied a Master's in Materials and Engineering Science at St John's College, Oxford, and a Master of Science in Materials and Manufacturing Management at Sheffield Hallam University. He worked for Tata Steel, which was formerly British Steel, and Chorus for 13 years, including 5 years as technical manager of the Old Oak Steel plant in Rotherham. And is now technical director of an iron and steel foundry in Chesterfield, Derbyshire. He got his first telescope last February. Now, this is obviously several years old now, this information we were.
About 9.
Pardon?
About 9 years old.
It's about 9 years old now, which was a 5-inch Newtonian, which only had for 6 weeks before upgrading to a 10-inch, and now uses a 12-inch Dobsonian to visually observe deep sky objects, as well as several smaller telescopes for astrophotography. His main interest is spaceflight and astrophotography, particularly globular clusters. Now, I was looking at the information on our website about him, and he was recorded as having done 7 various subject talks over the years he's been as a member.
At least.
Well, yes, I mean, they're the only ones that's actually been recorded by somebody onto the system. And that runs from 2016 to the present day. So that's a good record when you think about it, because a lot of them are not your night skies.
No.
There's various other subjects that were broadcast from you. So hopefully we'll get a few more in the future. So if everybody could put their hands together and welcome Andrew Kirton-Vaughan. Thank you.
Right. Right. Thank you very much. Welcome, everyone. Good evening. Nice to see people joining still. So we're going to talk about the spring sky tonight. Obviously, we've missed the first month of spring, and it was a very nice month it was too, finishing today. So I've skipped out what happened in March because it's past now, so we'll leave that one. I was really just concentrate on what's in the sky in April and May this year. Obviously, this is for the UK-ish sky, probably covers most of the Northern Hemisphere. Obviously, timings are slightly different, but it gives you a flavour of what's available for viewing. So, brief overview, we'll look a bit at the moon and planets, a few comets, and well, a comet and meteor shower that might be around, a couple of other interesting astronomical events that are going to happen over the next couple of months, and then we'll go through a couple of the major constellations that are well positioned in the sky at this time of year and what objects can be seen within those constellations. I'll start by saying the observing prospects for planets in the next couple of months is probably the most abysmal I've ever had to report while giving one of these presentations. There pretty much is 0 planetary observation opportunities in the next couple of months, and that's because most of the planets are in close vicinity to the sun, either in front of or behind the sun at the current time, and there's no real opportunity to see them. If they are above the horizon at any time, it's typically an hour or so before dusk or after sunset. So there's no real chance to observe many of the planets. The only opportunity really is at the end of April. It's been one of my goals for about the past 5 or 6 years now, is to try and observe Mercury. And there's an opportunity this year on the 28th of April, which I think is sort of midweek. And Mercury will be visible in the evening sky after sunset. It will be relatively high, 16 degrees. That's one of the highest I've ever seen it. Possible to observe it, and it will be relatively bright, about magnitude 0. You will need a very clear view of the western sky. So somewhere like the observatory is an excellent place to try and observe from. We've got a nice clear western view. There are some trees on the horizon up towards Hoover Stand and past that way, but relatively flat view there. So I might try and take the opportunity to do that now that the observatory is available for use again. Also, the last couple of years it's been closed because of COVID. So that's really the only planetary observation opportunity in the next couple of months for the major planets. Obviously, the moon is always there to be observed, and obviously that's a whole topic in itself of different opportunities to observe the moon. I'm not going to go through that tonight. So May, nothing. There's no planetary viewing opportunities in May of any significant quality that I can find. However, there are a couple of opportunities to observe some of the brighter minor planets at the current time. So also the minor planets, typically the asteroid belt, and two of the larger ones, which is Ceres and Eris, they are in good positions to be observed at the current time. Both visible in the around dusk from now. So at 9 o'clock is probably a point where the darkness is sufficient to actually go out and actually start taking some observations. Realistically, these objects are going to be extremely difficult to actually see with a telescope because they're down at magnitude 9 typically. So the only way really to observe them is to take some form of photograph of the area of the sky they're going to be in over a number of nights and look for moving objects. And also you can do this just by comparing images or by using some form of software that allows you to perhaps do a blink comparator and flick between images taken over different nights and look for effectively what looks like a star that is moved position from one night to the other. So I've got a couple of finder charts here for those two minor planets. So this is finder chart for Ceres, and that's in the constellation. In the constellation of Taurus at the moment, and you can just see in the bottom right hand side of the image there is the star Tauri. So that gives you a very good pointer. At the moment, the Ceres is just slightly to the north of Tauri, and throughout the next month, it's going to progress east across the sky, across that constellation. So, realistically, take a photograph of that area of the sky, wait a night, take another photograph, so on and so forth, and hopefully you will be able to observe the planet by effectively finding a moving star, which will be Ceres. Likewise with Eris, I think this is in Gemini this time. This is a very zoomed in view of the position, but there is quite close. I'll just flick back a couple of slides. So yeah, it's just to the west of Lambda Gemini star, and that gives you a good reference point in the sky to point your telescope or your camera or whatever with a telephoto lens or whatever sort of instrument you're going to use to try and record the sky in that position, to try and find one of these planets. This especially Eris is quite high in the sky. It's 50 degrees altitude. So again, if you've got any light pollution of that around you, should be hopefully get well away from that, and should be able to get some relatively dark sky images. So that's really it for planetary observations, because say that most of the major planets are very close to the sun, so they're all high in the sky during the daytime, and we can't observe them. There is one comet in the sky at the moment. It's not visible yet. It's the comet C2001-03 Pan-STARRS. So this is a comet that's been detected by the Pan-STARRS All-Sky Survey. The comet originates from the Oort cloud. So we've never seen this comet before. It's been taken many years to come into our part of the solar system. And it's on a trajectory that's very far outside the plane of the ecliptic. So it's coming in effectively from above us. It's going to cross the ecliptic towards perihelion, go under the sun, and then come back up through the ecliptic. And as it comes back up through the ecliptic will be our chance to observe it in the UK. Now, there is a risk because it's we don't know anything about this comet, that it could disintegrate as it approaches perihelion. I think the closest approach is about 0.3 AU, so it's quite a close approach, and the comet may disintegrate. At the moment, it's still about 3 weeks away from perihelion, and it's about magnitude 10, or I think it might even be magnitude 18. It's very, very faint at the moment. It's expected to hit magnitude 5 at perihelion, and then when it becomes observable to us, if it becomes observable, it should be somewhere around magnitude 7. Obviously, at the moment, it's so far out and so faint that we don't really know whether it's going to have any form of tail, any type. So it's really a wait and see what happens towards the end of April, and see if this comet survives its closest approach to the sun, and whether it's something that may be observable to us. So this is on the left, we've got the predicted magnitude curve. So closest approach is in late April, and then it should be visible to us around the 7th or 8th of May, and it'll be in the constellation of Perseus. And on the right, you can see find a chart for it. It's going to be moving quite quickly across the sky as it comes up through the ecliptic plane and heads back out of the solar system. So I think it's really a case of there may be opportunity, but watch this space. So it's going to get faint very quickly. So there's probably only going to be a week, maybe 2 at the most, where it might be bright enough to observe, probably through imaging, because I think it's going to be observable after dusk. The sky's not going to be that dark, and it's going to be down at probably magnitude 7 by then. So realistically, it's not going to be a naked eye object. It's going to be something that you're going to have to try and take an image, see if you can capture it if it's still there. So possible opportunity for a comet, but a bit unknown yet as what we're going to get. There is one meteor shower in the next month. It's the Lyridge meteor shower. The peak will be on around the 22nd of April from dusk onwards. The viewing will be favourable, but it's not a high intensity meteor shower. You'd be lucky to get one meteor every 3 or 4 minutes. So nothing particularly spectacular to see. There are meteor showers with higher meteor rates, but they tend to be the radiants tend to be very low to the horizon, and therefore, again, unlikely to get particularly high actual meteor rates. So nothing really exciting from the meteor point of view in the next couple of months. Obviously, as I didn't mention when we talked about moon and planets, the sun is always there to be observed if you've got the correct equipment. Again, solar observation is a different talk. We had an excellent talk last week by Andy Deavy on observing the sun, and people like Mike Nichols, who's with us tonight, is again another expert on solar observation. So I'll leave the discussion on observing the sun to those guys, because that's really their field of expertise. We have got some good ISS transits coming up from about the 7th of April for about 2 weeks, with quite a few ISS transits. They're going to be, the sky's still going to be moderately bright when those happen, but they are very bright, so it may be able to observe them. But towards the middle of April onwards, there are the really early morning events when the sky will be a bit darker. There are several other ones at more convenient times, but they tend to be low to the horizon, sort of 15 degrees to the horizon at the highest point. So didn't put them in this table, but the ISS observation opportunities will be there. And following on from that, there are a couple of ISS, excuse me, ISS solar transits predicted, and a couple of these, that'll be a double one actually on the 4th of April. So that is, I think that's Monday. Will be a double transit visible from the close vicinity of the Swinton area. And I've got a couple of finder charts in the next couple of slides to show you that. The second of these, although it will be a bit lower on the horizon, will actually last for 4.5 seconds, which is one of the longest solar transits I've seen being predicted on Transit Finder, which is a really good website that I use to find these events. Also predict lunar lunar ISS transits as well. But the solar ones are the ones that are in the next week or so. Obviously, this is subject to the ISS not changing its position significantly in the next week or next couple of days. Also, the usual health warning with observing the sun. Only do so with the correct equipment, either white light filter like Barda solar film or other white light filters, or obviously a Hadron Alpha bespoke solar telescope. No other form of optical aids should be used. You will need some form of camera where this takes high-speed images. So we're talking about, you know, several hundred frames per second, ideally, attached to a telescope or a lens pointed at the sun with the appropriate filter, and either a very accurate clock or a large amount of storage space on your PC laptop to record a significant length of video. With regard to things like times, if you want to try and observe this event, I would suggest that you keep an eye on Transit Finder website and check the predicted accurate timings, probably on the morning of the event, just to check that in case the ISS changes its position, it can shift the transit time. Even if it's by 5 or 10 seconds, it makes a massive impact on when you're going to start taking your image captures. So this is the first transit predicted at the moment. It's on the 4th of April at nearly 3 minutes past 4 in the afternoon. The blue marker point is is on the central line where you'll get the best viewing point from. So it's only sort of 2 or 3 miles from Swinton. The green point is our observatory at Hoover, just for reference. So you've really got to go to somewhere at Wombwell, I think probably Goldthorpe. Not you may want to go there. They're on the sort of the line of central transit, and that happens at say, 3 minutes past, just before 3 minutes past 4. And if you hang around in that, sorry, that should say 1913, not 913. My mistake. So at 7:13, there'll be another pass, and it's again similar location because of the position of the sun at that time. The path which you can observe the event is significantly wider. This is the one where the predicted transit time is near 4.5 seconds, and you will get most of that from Swinton, Mexborough, Clemensborough. Again, if you're in the sort of Wombwell type, probably quite close to the RSPB reserve, that location, that's right on the optimum position for observing the event. So a great opportunity to try and capture an ISS solar transit. I think 4.5 seconds is a huge length of time for the transit to actually take place. So really good chance to capture that if possible. So that will be Monday. Yeah, Monday afternoon, Monday early evening time. So that's the sort of brighter events in the sky, and we'll go on to look at a few of the other objects that can be observed in the night sky throughout the next couple of months. And realistically, in this time of year, it's really galaxies and a few clusters as well that are in the optimum position in the sky. Also, there are a number of circumpolar constellations, and I'm not really going to cover those in this talk, because they can be covered. Generally, tend to cover those in the winter time. These are really the constellations that are in prime position for observing at the current time. So, but this is a map of the constellations, and green is obviously the plane of the ecliptic for us, the northern hemisphere. And so we're really going to be focusing around, I don't know if you can use my pointer. So we're looking at the area around Leo and Virgo and Comets, and there's also just above it Canis Venatici as well. As you can see from the different symbols on the map, predominantly rich messy objects anywhere in this area are galaxies. And that not only covers the Messier catalogue, there's also quite a lot of Caldwell catalogue galaxies, and obviously a huge number of NGCs in there as well. But we're really looking into the away from the Milky Way, looking out into the deep space, and we're seeing deep space, objects outside our own galaxy. And there are also a number of globular clusters as well. You can see M53, M3 are in a really good position for observing at this time of year. So we'll also look at a few objects now. I'm going to also just very briefly talk about a couple of objects in Monoceros over here. It's a very early evening observation, so sort of observing probably from now, which is just after 8 o'clock, probably through to maybe 9:30. It's quite low in the sky, but it's some interesting objects, and there's some clusters that are worth looking at. So this is a star map for the constellation of Monoceros, and there's a couple of clusters in there, M50 and M48, that are really good observation objects to observe. It's the sort of thing you can observe with binoculars or a small telescope. You don't need a fancy camera or a really big telescope to observe open clusters, really. So this is a screenshot from Stellarium, my favorite planetarium software I like to use to find out what's in the sky, positions, times, etc., etc. Obviously, there's other ones available if you want to choose them. This is M50, and this is the frame of reference. I'll just move Mr. Hood out of the way, who's in my corner of my screen. This is the sort of frame of field of view that you'd get with a standard SLR camera on a sort of 1 meter focal length telescope. So this is the Messier 50, the Heartshaped cluster. Again, it's a messy object, so it was discovered by, well, it was recorded by Cassini. It was again rediscovered by Messier. It's about 3,000 light years away from the Earth, and it's got a radius of around 6 light years, so it's quite a big open cluster in terms of its volume and space. There's about 500 stars in the cluster, totaling around 300 solar masses, but it's a relatively open cluster. There's quite a high density of white dwarfs in there. Okay, open cluster. There's no particularly defined shape of the stars or pattern or layout. As with many of these clusters, it's been named the Heart-shaped cluster, perhaps when you can only see half a dozen or a dozen of the brighter stars in the cluster. If you were going to obviously observe this with some form of photography, you're going to pick up a lot more stars, and perhaps that initial shape that someone's used to name the cluster might be lost. But a good object to try and observe with, say, some reasonable binoculars. It's relatively large. And then we've got the Beehive cluster, perhaps a bit more famous cluster, again in Monoceros. It was actually misrecorded by Messier originally and given an NGC designation, obviously, which is from the Herschel catalogue. but then it was re-identified that he'd made a mistake, and the two objects were catalogued together later on. It's about 3,000 light years from the sun, and it's got quite a high solar mass of around 400 to 500 solar masses. So actually quite a lot of stellar mass within the cluster. No huge pattern such in the cluster. I can't actually find any description of why it's been called the Beehive cluster, but it's quite quite a famously named cluster that people can observe. So these two constellations, these two objects are monosterous. If you want to observe them, say now, next couple of weeks, really, it's the best time. Probably March would have been better, but we've also missed that with this presentation. So focusing back on the three main constellations that we can view in the springtime: Leo, Virgo, and Comets. And these are really, constellations that are very, very rich in galaxies. So this is a screenshot of the arrangement of the constellations at about midnight, 11 o'clock. In our position in the UK in the southern sky, so you can see Leo and Virgo and Comets. They're relatively low. So the star there that I've marked is 50 degrees. So they're in the bottom quarter of the sky, but these are the highest that they get within the sky, and these are the best. This is the best time of year to observe the constellations and the objects within those constellations. So there's at least 15 to 20 Messier objects in this part of the sky. So that's about 15-20% of the Messier objects in total. I say most of those are galaxies, but there's hundreds, if not thousands, of fainter galaxies that can be observed in this part of the sky. I haven't got it in this presentation actually, but a few years ago now, I'll say probably near 5 or 6, I pointed a small telescope of mine, 70mm f5 refractor, at an area in around Leo, and I think when I did a plate solve in PixInsight, there was over 130 galaxies picked up in the image, and that's just in one moderately wide field frame of this part of the sky. So there's thousands of galaxies that you can pick up with an image. Obviously, if you're doing visual observing, then much more of a challenge. But there's quite a lot of brighter galaxies that can be observed. So if we look at Leo, there are two main galaxy clusters within Leo. There's the Leo triplet, which is around M65 and M66, and then you've got the other cluster of galaxies around M105, M96. So I'll look at the Leo triplet first, perhaps the most famous collection of galaxies, maybe other than Messier 81 and 82, which is obviously a much easier object to photograph in the autumn and winter time. But this is the Leo triplet. Consists of Messier 65, Messier 66, and NGC 3628, which is the Hamburger Galaxy, the one that I've picked on at the top left. Obviously, on this image, it looks like the larger of the galaxy, and perhaps you'd say, well, why isn't that one got a Messier classification? Obviously, these are this is sort of a hybrid between a star map and deep, high quality images that have been superimposed on it. But in reality, this galaxy is significantly fainter than the other two, and therefore why it probably wasn't picked up by Messier. It's also edge on, so it doesn't look as like a fuzzy blob, which is ultimately what Messier was looking for. He was looking for comets, and he classified objects that he thought looked like comets, but obviously ultimately weren't because they didn't move in the sky. So you can see from Messier 65 and 66 at the bottom, they're both intermediate spiral galaxies. and they are moderately face on to us. Quite difficult to observe visually, or unless you've got a reasonably large telescope, probably something like an 8-inch Newtonian or larger. It's going to be quite a nice, moderately highly magnified, but quite a bright image as well with a fast focal ratio. And you're going to need good dark skies or reasonable dark skies, and plenty of time for your eyes to acclimatize to that environment before you can try to visually observe these objects. I'm hoping to try with my 12-inch Dobsonian, but I'm not sure where I am. The light pollution is going to be low enough to do that. I may look to put it in the car. Hopefully it won't misalign too much, and take it a few miles from my house out into the Peak District towards Hathersage. And there's a nice car park there that's quite regularly used by people in Sheffield to do observations, and see if I can observe some of these fainter objects in the next couple of weeks or so, assuming we get some clear nights, which we haven't got obviously today. After I think all forms of weather have happened today: snow, rain, hail, sun, and everything in between. So this is the Leo triplet. This is a frame, again, standard DSLR, 1 meter focal length refractor, so nothing fancy, nothing hugely highly magnified, in order to get this framing. Because remember, galaxies are relatively faint objects. They have relatively low surface brightnesses, and therefore they do need a moderately reasonable length of exposure of an hour or so, at least, to get some form of a brightish image. This is M95, M96, and M105. So you can see M105 itself is very small. This field of view is slightly wider. This is with about a 0.6 focal length refractor, so a bit of a wider field of view than in the previous screenshot. But as you can see, even then, the galaxies are smaller. Obviously, they've got higher Messier numbers. They were found a little bit later in the catalogue because they are smaller and dimmer. But you can see here up towards M105, there are another couple of galaxies that are of similar size, probably slightly lower brightness. Again, this representation doesn't always give you a true idea of the relative brightnesses of different galaxies. There have been some interesting events like M95. There was a supernova observed in March 2012 in M95. So people have observed other events, other galaxies in these galaxies. So again, nice area to probably, again, image type observing is really what's most practical, I think, for these sort of objects. These ones especially are probably too small for us to observe with most of the equipment we'd have. You need really dark skies and large diameter Newtonian telescopes to really see these with the naked eye. If we move into the constellation of Virgo, there's a lot more galaxies in Virgo, and you've got the Virgo cluster up towards M86, M84, 87, up that way, which is a really dense region of galaxies, and that's the area of the sky that I see. I've got my wide field image of, where there's over 100 galaxies up towards that area. So this is area of sky at the top of Virgo, I just mentioned, and it's often known as Markarian's chain. And a significant number of galaxies. You can see it creates a bit of a banana shape across the diagonal of the top of the frame, as it's shown on the screen. So this is with a 0.6 a 600 millimeter refractor, so it's quite a large wide field of view. It's a standard DSLR type picture. So Markarian's chain is also a stretch of galaxies in the Virgo cluster. The galaxies lies on a smooth curved line as we observe them, and contain a number of Messier galaxies such as M84 and M86. There's many other galaxies in the chain that were discovered by William Herschel. and many of these are recorded with NGC numbers when they were published in the catalogue in 1888. Some of the brighter galaxies can be observed with medium to sort of smaller, medium-sized telescopes, sort of 6-8 inch and above. But you really need a larger telescope to observe many of the other galaxies. You might be able to pick up half a dozen of the brighter ones with a sort of medium-sized telescope. But a really interesting part of the sky to photograph. Every red circle on the screen is a galaxy of some size or brightness. So the image I have was taken with I think it's a 500mm or maybe 450mm field of view. So a really wide, it's quite a bit wider than this. So again, another part of the sky. So we've got in this frame alone, we've got 4 Messier objects with M90, M89, 58, and 59. M90 being the largest and brightest of those. Most of these galaxies are of some form of spiral because they're quite small. It's unlike, say, M33 or M31 where it's very easy to, or M51 where it's very easy to pick up the spiral structure. It's really much more difficult to do so with these galaxies because unless you really whack up magnification and therefore the imaging time, it's going to be difficult to get enough light to really pick up the structure in most of these galaxies. This is perhaps one of the most more famous ones in Virgo, which is M104. It's called the Sombrero Galaxy. As you can see, it's an edge-on galaxy. So we see the sort of slightly edge-on. We see the shape of it like the brim of a hat with a bright core. Obviously, this is in Virgo, as we've said. It's about, the galaxy itself is about a third of the size of the Milky Way, with a bright bulging nucleus, and also a significant amount of dust lanes, which is the shadow we can also see in front of the bulge as we look at the galaxy edge on. It has a brightness of a magnitude 8, though obviously galaxies, the brightness is spread over a large area and therefore themselves are quite dim and difficult to observe relative to other stellar other objects we'd observe in the sky. There's obviously a supermassive black hole at the centre of this galaxy, and it's the quite an object that's observed quite a lot by professional astronomers investigating galactic structures. If we move up into the constellation of Comets, so we're just moving to the north of Virgo here. Again, you can see the significant number of galaxies and galaxy groups in this constellation, as well as Messier 53 and M3 just up slightly to the left into the Canis Venatici as well constellation. So this is a shot of M98. I've not focused in on it in the centre because I've got the opportunity to observe a couple of different galaxies in this shot. But as you can see, it's a moderately edge-on spiral. Again, they're quite faint. The spiral features, not particularly barbed. Is an interesting. It's more, but I think in this area for me, it's the density of galaxies and some of the larger ones where you can pick up a bit of shape. That's it's interesting to try and observe. I think for most of us amateurs who are not uber serious deep sky galaxy type of observers, it's really just about the challenge of trying to actually pick up the galaxy itself, especially if you're doing it visually. Obviously, with the imaging, you've got a telescope that's relatively well aligned. You're going to be able to point your scope and take an image of this without too much problem. So there's also using some brighter stars or plate solving software view into that sort of thing to direct you more exactly. So you've got Messier 99. So this is, you can see the Virgo Galaxy, which was in the left-hand side of the previous image, is now in the right-hand side of this image. So we've moved slightly to the east. And we've got a collection of galaxies here, one of which is M99. Another galaxy very close to it. You probably picked up by Messier as the same object with the sort of equipment he would have had. Obviously, with the more modern technology, or larger, better quality telescopes like the Herschels would have had, these objects have been separated and classified separately. And this is M100, again, all in close proximity in this part of the sky. Really nice face-on spiral galaxy. So it looks moderately similar to M51, obviously without the other galaxy next to it that it's going off. And then this one is significantly more magnified. This shot is with what you'd get with the C14 telescope we have at the observatory. So we're talking about three or four times more equivalent magnification than we've had in the previous screenshots that I've shown tonight. So obviously, that if you were going to use that sort of scope, you're going to get a lot more brightness of image, because it's an f11 scope rather than, say, an f5 scope that you might get if you had an 8-inch Newtonian. You do a 1 meter focal length at f5, so you'd get a much brighter image than you would with the Schmidt-Cassegrain telescope. But it's it's a sort of scale of object that we're talking about here. So this is the Black-Eye Galaxy M64, also in Comets. There's not much spiral structure can be observed in this galaxy, but a very beautiful object to try and record. But probably easier to, one of those that's, again, a challenge to try and observe visually. And I think if you could do that, you should be very satisfied with your observational skills. And as I said, there's quite a lot of, within this area, as well as messy objects, there's quite a few Caldwell objects, which are tend to be a bit fainter. So this is this galaxy here, Needle Galaxies, magnitude 12, whereas the previous one was magnitude 8.5. So a significantly fainter object, and also it's edge on. It's going to be more difficult to observe. My recommendation would be, depending on what equipment you've got, either go out and try and observe some of these galaxies, just see if you can physically see them naked eye. And obviously, if you are into photography or imaging like I am, it's really about trying to find a part of the sky that's got some interesting different shaped objects, and then how you can arrange those to form a beautiful image, and obviously how many different objects we can observe within that. And I said, finally, there is a couple of globular clusters around. There's Messier 53. These are good objects. This is a good object to sort of try and observe with binoculars. It's relatively high in the sky. It's quite. It's going to appear fuzzy, but reasonably bright once you've been able to locate it, and it's a good object to practice a bit of star hopping. So use a star chart. You can easily get them off the internet, or use a bit of software like Stellarium, like I've used tonight. Find some bright stars that you can easily find with binoculars, and then use those to try and direct yourself, hop across the sky to find these fainter deep sky objects. And that is what I've got for us tonight. So I hope I've given everyone a few ideas on objects to observe, both a couple of daytime objects, but also what can be observed with telescopes, with binoculars, and imaging equipment, depending on what sort of equipment you've got and what your what your fancy is, really. Obviously, you're going to need, just go outside now, it's 8:30, and it's probably dark enough to be observing. Most of the objects I've covered tonight, you can view from the point where you get decent astronomical darkness up until about midnight. Some of them will be observable a bit later, but I suspect most of us do our observing from the point where it gets dark till probably about midnight. There'll be a few hardcore people who will stay up all night, but unfortunately I can't be one of those. I have to go to work. So thank you very much. Thanks for coming to listen to my talk tonight, and I'll take any questions that people have got.
Okay, Andrew, thank you very much. As always, very informative, very entertaining. You've given me lots of things that I'm going to miss because of the clouds, but there you have it. Could I ask you to stop sharing your screen, please? Thank you. And we're looking for questions. Whilst I'm waiting for people to put up digital hands, Andrew, you talked about star hopping.
Yes.
Could you recommend any sites for star atlases that are easily printed out and disposed of?
I found one a couple of years ago. I can't remember what it was now, where you could kind of pick a limited magnitude. I mean, I tend to use I tend to try and use stellarium, and then in some ways create myself a bit of a sketch, because recently I haven't been able to find there was a website I found previously where you could sort of select a bit of sky and print it out, but I've been generally using stellarium, changing the limiting magnitude, and then making myself a bit of a sketch. I find that's easier because I don't want to obviously use a tablet or anything when I'm outside, because it just wrecks your night vision. So I've been using sketches really, because I've been trying to use my Dobsonian a bit more and sort of learn to move that around the sky, because it's not motorized, it's not a go-to, it's purely pushing.
Yeah, I think with star hopping, preparation is the key.
It is very much so, and it's having, I'd say, no more than half a dozen objects that you might want to look at, because you're going to take a lot of time to try and find the thing you're looking for. And obviously the view down a telescope is you always see a lot more than you perhaps drew on your star map, and it's good also to get an idea of. I like stellarium because I can put in well, what I've done in the past is put in the specific telescope I'm using, specific eyepiece I'm using, and then you can project a circle. Obviously you can create an effective virtual field of view, and then when I've drawn my sketch, or if I've had a star map, I've tried to draw a circle on the star map that's about the size of the field of view I expect to get, so that when I star hop, I've got an idea of how far it is from one edge of my field of view to the other. Because having a star map is great, but unless you understand that I've got to go 2 fields of view to go from that bright star to that bright star, it's kind of, you lose the scale, and then it's very, very difficult.
Yeah, it's having given a couple of talks about star hopping over the years, it is an art that needs practice.
Yeah, and the thing I found is having something on a bit of paper that says this is my field of view, that's to me been the key to being able to do it, because you need some form of reference scale. Otherwise you end up going far too far or not far enough.
Yeah. So, John Leach. Good evening, John.
Good evening, Andrew. Excellent talk. Really enjoyed it. Always do. I was interested in the ISS capturing that. I'll be at Whitby next week, so I don't think I'll be in the line of fire. I was just wondering, Andrew, have you actually tried to photograph the International Space Station as an object?
I got it once, yeah.
Right.
I managed to get it once across the moon. I only got about 3 images.
Yeah.
Didn't get enough frame rate at the time, but yeah, it's the moon. Obviously, it's quite, a lot smaller than the sun. You only get between sort of 0.3 and maybe 0.6 seconds to actually capture it.
Yeah.
And you need something that you need a camera that will do 200, 300 frames a second to really have any chance of really capturing it in any way, shape, or form. So, and you need to be accurate on your timings, but I'd say if you've got enough hard drive space, 20 odd seconds before it's going to happen, 20 odd seconds afterwards, you'll never see it on the you hardly ever see it on the screen. You just have to press start, hope it happens, and then watch it back and see what you get. Obviously, with it being 4.5 seconds, you know, then that's a chance that if you've got something like a PST or something, or any telescope with a white light filter, it should be slow enough to see it, and that would be quite interesting to try it. It's going to be relatively low. I mean, it's going to be 7:15 at night, so the sun is going to be quite low at that point. Hopefully, the skies will be clear enough on Monday to do that, but I'm not confident.
It should be interesting. Yeah.
Obviously, you know,
go on. Sorry, Andrew.
So obviously, if you're in a different location, you can use Transit Finder. You can put your location. You can put a distance you're prepared to travel in, and it'll tell you what's available.
Next week's gallery will probably show to us who managed to get it.
Yeah, well, I don't know if I'll get the first one because I'll probably be at work, but the second one's a possibility if it's clear enough.
Good luck. Right, many thanks, Andrew.
Okay, we're going to bring in the society room now.
See, Mr. Morris is waving at the back.
It's just me. I'm just going to follow up on what Andy and John have been talking about. I managed to capture a transit across the moon about 4 years ago, and basically I set it with 2 telescopes, 2 cameras. I got it on my Canon EOS. It was about 20 frames a second I was taking. And as Andy said, I started 15 seconds before it was due to start, and took 30 seconds worth of images, and then had to basically play back the images to see what I got. I did okay. It was spotty across the screen. It wasn't joined up, but I got a fairly jerky video of the space station across the moon. It was a full moon, which was why I attempted that. But it was literally a fraction of a second. I think it was like 0.7 of a second, the entire event.
Yeah, I think if you're going to use Transit Finder, it does give a very accurate indication of the centre line for observing, and the closer you can get to that centre line, the longer you're going to.
The secret is to check it.
Tony Morris wants to have a word.
Probably just one here for John. So Gary and myself did a transit of the moon, the ISS, and we used DSLRs. And if you're looking through the viewfinder of the DSLR, you can actually see, under some circumstances, you can see the ISS coming in. So you know when to press the shutter. So between us, I think we only managed to capture about 4 or 5 frames with the ISS between us and the moon. But because we're using two separate cameras, we're able to align the images in PixInsight and build a small movie. So if you've got 2 instruments, you've got a better chance of capturing it.
Yeah, I have actually captured it, Tony. I'm sure I sent an image off to the gallery, and it was purely by accident. I was basically recording the moon as video, and I noticed this movement, and it was the ISS, and of course I've seen it many times in the sky, just going over. But what I like to do, because I've seen someone else do this, is actually get a picture of the ISS a little bit closer up with a long focal length. And it's a challenge basically that I can't refuse.
I think Mr. Hood has got an excellent image of the ISS against the moon, and the section of the image with the ISS on, he's managed to expand it, and you can definitely make it out. You know, you can see the solar panels and things hanging off it. Tony,
I saw something on the web.
Just to say to John that we use Transit Finder, Gary and myself, and we use GPS geolocation so we could get on the centre line, so to speak.
Okay.
To maximise where we were. So we were south of Rotherham, just over the M18, near Guildford Hill. So that was our best location that we could find. So we did quite a bit of pre-planning. And as Andy said, you basically got to do the check on the morning, you know, in case the ISS has been boosted in its orbit. But it's worth really knowing where you are.
Yeah. Thanks again, Tony.
Yeah, I actually saw an image on the web today or yesterday where someone had managed to capture the ISS during a spacewalk, and they'd actually reckoned they could see the astronauts.
Challenge me, John.
Okay, I'm looking around for questions. I can't see anybody desperate to ask a question. Ladies and gentlemen, I think that just leaves me to ask you to thank Andy Kirton-Vaughan, not for just this evening, but for the several years he's been doing the job of observations officer and keeping us up to date on what to look at, and all the other talks as well. Andy, thank you very much for your service, and thank you for tonight. Thank you very much.